Right, today we're going to be looking at section 6.1 prep. I want to direct your attention to a couple of things. We're going to be looking at graphs and transformations, and so this is getting you ready for at least the graphing of them. I do encourage you to go to the ebook, so I'm kind of pulling it up from the side, the homework panel. The textbook does a great job of going over the transformations and showing you the basic parent functions. So in the textbook, it starts out with parent functions, gives you the linear, constant, quadratic, cubic, and all of the algebraic functions that we're going to be looking at in algebra. It then begins to go over transformations. So this is probably one of the better ways I've seen it presented in the textbook, so you can kind of see exactly what's going on. But you're going to be needing to get comfortable identifying different variables, A, B, H, and K, and it tells you what each of them does. So vertical translation, and it spells it out for you. So when you see an equation, if you identify K, you know it's going to shift it up or down. It gives you some examples so you can kind of see what that looks like in different functions. It then goes over horizontal transformations. And did I skip that box? No. Horizontal transformations listed here, and it shows you what it looks like in the expression. So when it's in the grouping symbol with X, it's going to shift left or right. Notice the negative, it's going to shift it to the right, and the positive is going to shift it to the left. We're going to explain that in more detail later. And then if you go all the way through, it shows you vertical and horizontal stretches and compressions. It shows you reflections. So do spend some time going through the textbook. It does a great job. In addition, in our Blackboard course, under homework videos, I've added 2 documents. So you have a parent function. The parent function is pretty much similar. They may give you a different name, but pretty much similar to the same graphs. You have linear. It even tells you a little bit of the symmetry, domain, and range here. And these are mainly the algebraic function. Has the integer function, which we don't really use very much, but it's there, and has the reciprocal and the reciprocal squared on the parent function document. In addition to the parent function document, I also have Harold's parent function. So this is one that I found online that I thought was good. It's in color, gives a little bit more information, but still has all the algebraic functions, constant, writes all the graphs in standard form, gives some information about the symmetry. If you go further, it gives more transcendental functions, conic sections with circles and ellipses, trig functions, which we won't need all those, but it's neat to have it all there. But if you go all the way toward the bottom, it also gives you some information on the transformations, and it gives it in the same language that our textbook does. However, it describes the transformations based on what you plug in and not what you see. So this is a little bit backwards than the way I explain it. So we'll refer to your textbook, but just showing you that all of this information is here in case you want to print it out or refer to it later. That being said, let's go ahead and tackle problem 1. It wants us to graph the function 2x minus 1. This is just a simple linear function. So you start with the y-intercept. Okay, this is in slope-intercept form. So I'm going to start with -1 and click the pencil. We're going to go to the y-axis, go down to -1, and click, and it makes a dot. And then we're going to use the slope, which is 2 over 1. So I'm going to go up 2 and then right 1 and make another point. Once that's done, I will tell it to connect the line. So you click one, click the other, and it'll make the line through those 2 points. Question number 2, we also have an equation in slope-intercept form, and we want to graph the equation. So again, I'm going to start with the pencil. I'm going to make 2 dots. I'm going to go to the y-intercept, which is positive 6. And then the slope is negative 3 over 2. So starting at 6, we're going to go down 3. And then we're going to go right 2. And then once we have 2 points plotted, we'll lock in that line, and then we can check it.